Happy Thanksgiving Day. What a good time to be alive. And what a good time to be sharing this space and to be talking about space. A very good afternoon. It's actually my evening. It's 7 p.m. in Botswana. A very hot day, extremely hot, which what we call our very hot today. We are on 35 degrees and sometimes it gets to 41. So, yes, it's pretty hot. So, a very warm welcome. Those joining us from LinkedIn. I saw we have a lot of visitors today from LinkedIn, joining us from Facebook and YouTube. We're happy to have you on this page. And I'm just going to give the mic to my co host, Mr. Alford, who will do his own introduction. Thank you.
We are so excited to have you, everyone. Thank you for joining us. Space. What a topic. It goes from the very tiny to the very large. So I'm Doug Alford from the Indie Ed Project. We're a charitable organization. We make easy science products. We're so happy to have you here. So we're going to be talking today. We call this episode From Atoms or Elements and to Us. So they're very small to us, but it's really gravity to galaxies. So without anything, we've got a lot to cover. Those of you who may be joining us for the first time, next page, please. We have the reason we're doing this, right, is globally, we've noticed a lack of understanding of science. And so we want to share the science, easy to understand. So that's the reason we're doing this. That's the why. Next page, the what is there's 10 topics. This is our 8th podcast. So if you've missed the other 7, Ms. Sally can show you the links and you can get all the other podcasts. We're going to cover galaxies, gravity to galaxies. We're going to talk about one-page summaries, overviews. We give easy, basic science, and then we build upon them. As we talk about the other subjects, if you don't catch everything, if you don't understand, that's okay. You've got all the source data, you can go back. I'm going to shut my camera off just to save bandwidth. Next page, please. We mentioned that space is a huge topic from the very tiny to the very large, but we're going to cover it with atoms and 2 forces. It's the parts that space and Earth and us are made of, the elements. Then we're going to talk about 2 forces of poles of gravity and the pushes that it takes rockets and spaceships to push against gravity and get off the Earth and go into space. So keep those 3 topics in mind, please. And then as we go through this, if you have questions and comments, please reach out to Ms. Sally. This is not just me talking. We want to hear as much as we can, especially from our students that are joining us. So let's cover some basics, some roadmaps, and space. Atoms. We all see the sun, and in the sun is the parts that the Earth is made of, right? All of space is made of. Atoms, all atoms are all the same, are called elements. Where do elements come from? They're made in the sun up to iron, which is number 26, but then it takes a star exploding to build all the other ones from 26 up to about 100. And all that has to come together to make us. What an amazing, awesome concept that we are made out of stardust, right? So keep in mind the parts and the atoms. Next page. Okay, perfect. The gravity. So what is gravity? Well, we all know that we don't fall off the Earth because gravity keeps our feet on the ground, but gravity is why the Earth and the other planets circle the sun. And so gravity is the force, right? So we'll talk about, but it's a wonderful force to keep us from flying off the Earth. But what about when we want a rocket ship to leave the Earth? And that leads us to our next force, and that's pushes. And so we'll talk about why it takes cars and even planes can move on the Earth, but they're not powerful to push against gravity and get off the Earth, and how it takes a rocket to push down the engine and the fire pushes down and it pushes the rockets up until they get going fast enough and they can escape from gravity. So if there's any questions, please interrupt. But next page, please. The goal of this podcast is to talk about space. We're going to then talk about time and astronomy and how it's the way we tell time in our names of our weeks, days of the week, and also our months have a relationship back to stars. And then if we have time, we'll talk about some easy topics and some harder topics. So that's what we're going to talk about today. Let's just get right started. We're really big about one-page summaries. And so we use the example of when people first went to the moon back in 1969, those of us who remember that. And we use these 8 steps. And so we'll talk about principles, problems, the plans it took, and again, more parts, how the atoms joined together to make the parts, how we sent probes to the moon to make sure it was landable, but people are involved. And we'll talk about what that lady standing next to and how she was the one that invented computer science. That didn't even exist before she actually invented it. We'll talk about how we made it to the moon and left footprints. And then what does all this mean to us? What are the impacts? So next page, please. So this is a lot of detail. We are not going to cover all this detail in this class because we're trying to keep it entertaining, exciting, but we want to make sure teachers have plenty of material they can go back to and reference back. If this was too fast for you, don't worry about it. You can go back and get to the topics that you need. So we talk about number 1, principles. Space is big. As we look at the night sky and you see those thousands of stars, and then you see those stars that are actually suns. That's astonishing. And some of those points of light to us are actually galaxies full of thousands or millions or more stars, which is astonishing. So the sun looks to us like a ball because it's so far away, but 1,000,000 Earths could fit inside the sun. That's amazing, right? So we have to learn some of the facts about space. More facts. Next page, please. So is light travels fast. In 1 second, it could go around the world 7 times. Light, even though the sun is so far away, it takes light 8 minutes to go from the sun to us. But we'll learn about other planets and how far away they are from the sun and how long it takes light to go from the sun to the other planets. You can see the picture there of Einstein, and he's the one that came up with the speed of light and some of his famous equations that if we have time, we'll talk about. If not, we'll leave that for you to go research. Key to our discussion of space is the fact that people on Earth have to overcome gravity. And so we talk about rockets and how, again, cars and planes, they move, but they are not strong enough. It takes rockets with enough power to push up. And you can see the Saturn V rocket there. Next page. So in addition to that, why did people have the space race? Well, there was a Cold War between 2 countries, and they used space race to show each other who was to chase each other. But half of the first space race rockets blew up. And it's important to realize that space takes challenges and it's not just easy to get there. Next page, please. So it takes a plan. Science helps us to plan. People on Earth wanted to go to the moon. How? And so the guy that's shown there with a chalkboard, because that's the timing and the technology back then, and it's a key point to notice what life was like before the space race, and now we have computers, right? There weren't computers before the space race. So on the right there, it shows that one country sent dogs into space first to make sure it was safe for life, and another country sent chimpanzees, monkeys, if you will. So next page, please. So it takes rockets to go into space. Well, rockets are made out of atoms and elements to make the pieces, the parts that come together as systems. Those of you who joined our conversation about nature, we talked a lot about nature and the atoms that become lifeless atoms to become life. Similar, it takes parts, atoms to come together through processes to make the rockets and the different systems that all have to work together. So it takes parts to get us into space. And it's a wonderful opportunity for us to learn more about science. But before people could go to the moon, they had to make sure that they could land on the moon. So people from Earth sent probes to the moon. And those of you who may have watched the news recently, India just sent a probe and it landed on the southern pole. It was astonishing, great achievement there, great science. So it takes probes to make sure the moon was going to be safe. Next page, please. All this took people. And so the picture there is the lady is the one that invented software engineering. She came up with the term, she came up with the process. There wasn't even software as they were trying to make these computers. So she's standing next to a printout of all the code, the computer code that it took to drive the Apollo guidance computer to control the spacecraft from the Earth to the moon and back. But so she's standing next to it. You can imagine how hard it would be to find a problem and to solve it. And then the picture in black and white is her in a simulator going through all the code. But it took lots and lots of people, lots and lots of skills. And it's important for us to realize today that while science is interesting, it can be and should be a career for us to improve our lives. And so we learn these things about science so we can apply them in our lives to get money, to live, but also to improve our societies. So cutting right to it, it ended up with people actually going to the moon. How astonishing is it? And what's different about space, right? And how the fact that the moon doesn't have air. Remember the previous podcast where we talked about air, water, and food. Well, all that humans had to take all that with them. But how awesome it is that we were able to leave prints on the moon. Well, next page, please. Well, what does all this mean to us? Sorry, one more imprints, right? So during the process of going from the Earth to the moon, people made computer chips to control the computers that had to guide the spaceships. And that was some of the first computer chips. And how astonishing it is to have just very few transistors in those chips, and now we have billions. But it took people and the science to go from where we are on Earth to the moon, right? But the moon isn't just the end. And these space telescopes, both the Hubble and the James Webb, show us like travel guides all the places in space where we could go, and how exciting it is today to live and be able to know that there is so much more to learn about space. So if there's no questions, we'll just press on. If those who remember the second podcast, we talked about airplanes, and airplanes happened in 1903. Well, it took 66 years for people to go from first flight to land on the moon. That's amazing. If you think of the technology from the cotton covered cloth wings of the first planes to spaceships that landed on the moon, 66 years. So let's set a goal in the next 66 years from the first moonwalk, be 2035. Let's make sure we get back to Mars. How are we going to do that as a people on Earth? We're going to have to learn science. And so together we can work together to get to the moon. Seeing, is there a comment? Okay, we appreciate you texting any questions. So it's important for us all to realize that there's ebooks for both teachers and students and parents and anybody else interested. There's also videos. Miss Sally, I think we were trying to show a little bit. Just let me know if you want to be able to show a little bit of the videos. But there's videos available through Miss Sally that talk about the moon race, that go over what we just talked about. But in addition to that, there's a second one called Moon Shoot. And it's the 12 steps of science that go from how gravity glues our feet and all objects on Earth, and how it took engines and fires and forces to get off the Earth. Then once you orbit the Earth, you had to get more fire, more push, and it got you out of Earth orbit on way to the moon, but it took steering and guidance and computers to keep looking at where are you, because when you leave the Earth, you have to shoot for where the moon will be in the 3 days it takes to get there, not where the moon is, right? And so you're constantly looking at that. And then all the other steps and the science that it took to get to the moon and back. And as importantly, what do we do next? How do we work together to go to Mars and beyond? Space tells us so much about ourselves on Earth and also our place in the galaxies. There's so much to learn. It's a little of a challenge to keep going from the very small and the atoms to the very big in space. But just take a quick pause. Remember where we talked about in Air, Water, and Food, how, or in seasons, how the Earth turns, and so we have night and day. It tilts, and so different amount of heat hits us, so we have our seasons. But then the Earth actually orbits the sun, but so the Earth turns and spins around the sun, but the whole sun and our whole solar system is moving as well. So we can talk more about that, but how amazing it is about space as we look at the night skies and we find our place in it. Next.
Doug, maybe we can have
Awesome.
Teacher Nonofo. She loves all things space. I learn a lot about space from her. So she can get on stage and introduce herself. Teacher Nonofo, the mic is yours.
Oh, thank you very much, Sal. Thank you. And hello everyone. I'm sorry because my camera, I don't know what happened to it. It doesn't come on. I've tried everything that I can to have it on, but something just happened to it. So to say who I am, my name is Nonofo and I am a mathematics teacher at Maran Junior Secondary School, and I love space. I have some STEM programs with my students at my school, and the reason why I love space was because when I started learning about space, most of the questions that I used to have when I was at junior secondary school, because I used to question a lot of concepts, but at times I was told there's nothing like that. So there was a time that I felt, you know what, I suspect I'm not so smart, or I don't understand something. People understand, but I don't understand. So I just you know I resorted to cramming or memorizing stuff because I didn't understand. So I passed because I memorized, of course. So when I started learning about space, as old as I am, most of the questions that I used to ask were answered. So I would share some of those ideas with my students. So I think they were at the point, or they had the same questions, but they couldn't ask them. So there were a lot of aha moments, during those sessions that I would have with my students. So I never stopped learning. I wanted to learn more and more about space, just so I could share with my students, and my students love space. So yeah, in a nutshell, that's who I am.
Fantastic. Thank you.
Thank you.
Thank you, Teacher Nonofo. Sounds like Doug wanted me to say something. And since I love my voice, I have to say. So, Teacher Nonofo is one of the most active teachers I've come across, and we do a lot of projects together. So, just so you know, teacher, you can maybe tell your students who are listening that we're going to have a question and answer session when we're done. And the winners will get books. We're going to give them, if they want ebooks or printed books, we'll make arrangement for that. And you're also free to interact and ask questions. Thank you very much, and thanks for your intro. Over to you, Doug.
So we've got so much to cover. As you know, space is a very big subject, so we're not going to cover it all. But we do want to mention about many countries of the world, especially from Latin and Spanish and French, base the days of the week after names of the planets. English did that, and then as different conquerors came to England, they changed some of the names, but some of the English day names are still show Sunday, Moon Day for Monday, right? Several of them have changed to, like the Vikings would change some right when they came in, but then Saturn's Day is still Saturday. So it still shows it in English, but even the other languages show it even more. But in addition to, sorry, go ahead. Is there a question?
No, not yet.
Okay, no worries.
Sorry.
In addition to the days of the week showing connections to the planets, the 12 months show connections to groups of stars, constellations, that people on Earth could see these stars as the Earth orbits around the sun in a year. We can see different stars. And so they would take these points of light in the sky and give meaning to them. And so the zodiac shows a connection from people on Earth to the stars. And so we call them lucky stars. There's 2 videos on the days and the months. So next page, please. So we like to tell stories because I love stories. It connects science to our daily lives. There's an interesting point that those of you who love Disney movies and cartoons, when Walt Disney, the starter of that company, he was back when they were first trying to go to the moon, and he made space exciting. He would be on TV every week about talking about space and getting people excited about space. And so he would meet with the scientists, and so he made science cool. And so there's a connection between the cartoons and the cosmos. Another pause point is the story is told of Isaac Newton back in the 1600s when he was sitting under a tree in his place in East England, and an apple fell down and hit him on the head. How much is true? How much is urban legend? Who knows? But the point is, it made him think about, why does an apple fall to the ground? And just 400 years after he noticed that, wrote books about gravity, came up with math and science about gravity, then people were able to walk on the moon. And so, but it took him thinking about apples falling on Earth to get us to walk on the moon. Next page, please. One of the things that we do is to integrate all this, right? Because science isn't just people knowing different facts, it's people working together in teams. And as we pointed out, it took teams of people to make rocket ships and satellites and probes, and it takes people working together with science. One of the examples we give is the guidance, navigation, control electronics that was made to guide the spaceship. So please, Ms. Shelley, cut in any time. Are there any questions?
We have a guest. She can say hello. Miss Paulette, good to see you. And
Hello.
she loves e-learning, all things STEAM education. Yes, over to you.
No, you carry on. I was thoroughly enjoying myself.
Okay, thank you.
One of our challenges as we talk about a subject so small and so big is making sure we don't get lost in between, right? So let's go to the next page, please. Is we all who love space get an opportunity to pause and go to the very tiny atoms. And yes, there's different models of the atoms, and it's not something we can see. But one of the models is you have a nucleus in the center, like the sun, and you have electrons going in orbit around them, spinning in orbit, which are like the planets. And so there's a similar understanding, at least, about atoms and Earth going around the sun. But then we'll talk more about this, but then the whole sun moves and our whole galaxy is moving. That's amazing, right? Just to go from the very tiny to the very large. If there's no questions, let's go on. So Those of you who haven't seen the book, Seasons, Turn, Tilt, and Orbit, I recommend you go back and look at that. Just a fun book and video that talks about the science about life on Earth here, but now with the aspect of space. So we always take a pause and go over easier books. Not all students are ready to talk about the cosmos. Some of them are going to need to know more about space. And so there's a simple book based on my father and his experience as an Air Force navigator when their electronic and their compass went out, and how he had to use the stars to get back, right? And where it was able to navigate with the stars. That's a personal experience, but it's a fun book. We hope people will like that. Next, please. In addition to the easy, we want to make sure that we give plenty of materials for those who are more advanced. And so we talked a little bit about this, but there's the moon shoot, and there's plenty of data there that you can dive into, the daily science, and then how that all applies into space. And it's amazing how the science we learn step by step can build, and how we can take those steps and apply to things like going to the moon and more. Next is just the script. So next page, please. Okay, so we talked a little bit, covered a little bit about it, but it's so easy for all the students and hopefully adults to say stars, right? We look at it. Sometimes in the cities, it's hard to find a darkened sky, but looking at the dark sky, and how can we not be astonished? And how people on Earth once thought that all of space revolved around the Earth, and how today we know that the Earth revolves around the sun, which then is still spinning in a galaxy. But how what we thought were points of light in the sky turned out to be actually more galaxies, and how we're learning more and more about space. But even though it is so vast, the basic science is easy to understand, right? We talked about how matter, how atoms pull together, how the easiest, simplest atom, hydrogen, comes together, and then in big balls of it turn into the gravity pulls it together. It gets so hot that the two atoms of hydrogen join together to make helium, and when it does, it gives off energy and light. And that's through a process of long time getting outside the star comes to us. We get sunlight on Earth. We've talked about how plants turn that sunlight into the food that we eat, right? So we take science from looking at stars in the sky to how it applies to us on Earth and our daily lives. And Star Time helps us do that in fun ways, looking at the names of the weeks. So let's just take a quick look at it. Now, next page, please. So in English, it's still called Sunday, right? But it is, and it's no wonder that people in ancient time worship the sun, right, and the sunlight. But it's a good opportunity to take a pause and talk about photosynthesis and how we take sunlight that came from the fission on the sun and it turns into plants, and it turns into our food that we eat. And there's additional complications that we can do. But the sun is huge and it's massive. But it's not on fire. It's not something that's going to burn out. It's billions of years old, and it's going to keep burning for billions of years more. Next page, please. Scientists think that a long time ago, a planet about the size of Mars smacked into the Earth. It then knocked off the moon size, right? And that's why we have the moon. It's why we have the tilt, and it's why we have Mondays. And so we can talk about Mondays and the moon that we see and how people actually landed on that with science. But the moon is about a fourth the size of the Earth. One of the things that we struggle with as we talk about space is we're constantly talking about size, from the very tiny to the very large. And so we'll talk more about how we measure distance by how light travels. Like we mentioned, light goes from the sun to the Earth in 8 minutes. Next page, please. In French and Spanish, they still name Tuesday after the planet Mars. English used to be called after Mars. Then when the Saxons came from Germany, they changed it to their god, but it's still tied to the god of war. And so it's why the god of war. Well, Mars has a reddish tint to it, right? And we know that blood is made from iron oxide that makes it the red. But it's interesting how light travels. Remember, light travels from the sun to the earth in 8 minutes. It takes 13 minutes for light to travel to Mars. So now you're starting to see the distance, right? And we call it astronomical unit. Let's go quickly through these. Wednesday it was named after the planet Mercury, and right, and Mercury is closer, and so while it takes 8 minutes to get to Earth, light only takes 3 minutes to get to Mercury. We'll leave the rest of that for you to go look at your time at your own speed. Next is Thursday, which English we name it after the god of Thor, those who've seen the movie about Thor, right? But it still ties back to the planet Jupiter. And it takes 43 minutes for light to travel from the sun to Jupiter, right? And so amazing. And over 1,000 Earths could fit inside of Jupiter. That gives you some of the size we're talking about, right? And that sunspot next is Friday. So Friday's tied to Venus. And Venus, it takes 6 minutes. The first star that we see in the sky is not really a star. The first thing we see is Venus. So it's fun to think about Venus. And next, let's go to Saturday. So even English still keeps Saturn's day is Saturday. And we can talk about the rings and what are they made of and how they're thin, right? And Saturn is one of the fascinating planets with different things. But how long does it take? It takes 80 minutes for light to go from the sun to Saturn. So this is all giving us perspective of how long. It's 10 times as far from the sun as the Earth is. Next page, please. Then we get into the months. And as we mentioned, so a quick data point, as we look in the northern skies, we see the Big Dipper. And the Big Dipper, it's shaped like a big cup that you can dip into a bucket of water and get a drink. And through the year, that dipper looks, from our viewpoint on Earth, it looks like it's rotating around the North Star. Well, what we know is those stars aren't moving, we're moving. And as we move through, it's called the ecliptic. As we move through our orbit around the Earth, we see different groups of stars, and that's what gives us the names of the months. We're tied to the original star clusters. In English, we've changed those names, a lot of them, and we go through the different. Here's a couple examples. Next chart, please. So the zodiac is called and why they picked a sea goat, who knows, but they picked a sea goat, and then the stars make roughly that shape of the sea goat in the sky, and that's why January is named after the god that looks forward and back. So next, these are just a couple example of months. March, remember Mars is the name of the god of war. Mars also the name of our planet, so it's tied to Mars. But a data point is when the Romans conquered England about 2,000 years ago, they changed the name to their god of war, Mars, which is also the name of the planet. Next page, please. So to recap, right? Gravity. We take a pause and say, how astonishing. We can see gravity when things drop to the earth. We can see things when we slip. Then we talk about not just noticing the gravity on Earth, but how important that is to the Earth going around the sun and the sun then spinning around in our galaxy, right? In addition to that, we point about the moon in between. And it gives us an opportunity to talk about, well, does the moon have its own light? Right? No, the moon bounces light from the sun. So it gives us many opportunities to talk and to bring in the learning that we've had in different podcasts, like podcast number 1, Easy Ideas. Next page, please. Okay, we've covered a lot of space here, right? Literally. And we want to take a pause. Are there any questions before we go into some of these topics? Ms. Sally, over to you.
Thank you, Doug. Let me check. I can see we have Hillary, we have Nonofo and Colette. Please let me know if you have any questions. You can just unmute and ask. But this is so fascinating, and I just wish there was more time because it's quite exciting and funny when you're giving meaning to days of the week. To me, Monday just Monday, and I'm just thinking, I've never even thought about how did it come to be Monday. January, just January. And just to see the reasons behind leaves you with so many other questions that you'd like to find out. How did the naming come about? So I'm not sure who would want to. Colette, you have a question
Yeah,
on and off?
I think it's a great way of getting kids interested in the stars, the names of the days, the months. It's also interesting in how it's all proven and validated and science, and it kind of ties it all together. And I think people, especially my son, he would have loved this because it's a complete circle. It explains everything and the whys and the hows. So I think it reads and works very, very well.
Absolutely.
Thank you.
Doug? Hmm.
One of the important things then is to bring space science into our lives, right? And make it real. So as students look up at the stars and see them and then realize that each point is actually a big sun, right? This is far away. But one of the criticisms that the countries that spent all the money during the space race was, why are you spending all this money in space, right? And the answer came back, well, you're spending the money on Earth to go to space. And then huge impact is if you look at and you contrast telephones from the 1960s and today, where they were landlines that were locked in place versus our smartphones that we have today. And a big part of that journey is the fact that we were on a space race, that we had to make electronics small enough. Computers were room size to begin with. We had to get those small enough so they would fit on a rocket, right? On a spaceship. And to do that, we had to get smaller and smaller. And so that helped fuel the whole electronics, the whole digital devices that were spun off. So when students are holding their smartphone or their tablets, right, or working on a computer, we can talk about tying that into the space and how people had to learn the science. And they're getting the benefit today of even the technology of radio frequency of the radios in the smartphone being able to connect to each other, because we had to talk to spaceships that were hundreds of thousands of miles away, right? And how did we do that? So it's given a term spin-offs from the first space race. While it was definitely a conflict between countries and ideology, we can learn from that. And now a lot of people like myself think that we're in space race 2.0, and we can learn from the conflicts of the past, and let's work together as we go back into space and go further, right? So not only we're learning the lessons and the science, but as we understand more about the science, we understand more about ourselves. There's a story told about atoms on Earth, and as people were discovering the elements on Earth, one of the things they came up with was a way to, when you burn a substance and then you put that light through a prism, then it gives what's called a spectrum band, and it shows different colors, and then there's some black areas. And each element has a different, it's just like a fingerprint or a DNA, if you will, of an element. And so they would try hydrogen and give out certain bands. And then they were looking at the sun during an eclipse. And they said, and they captured that light from a sun. And they said, we don't understand this. And they cut right to it. They discovered helium on the sun before we had helium on Earth, before we discovered helium on Earth. And helium comes from the Greek word helios, which means sun. And that was why. So it's fun to tie these stories directly into our lives today, right? And that students can see how important it is for science. Learning science on Earth helps get us to the stars. Miss Sally, are there students on listening? I want to make sure we listen to their voice, or I'll continue on. But if we could just pulse the the audience, please. Any questions?
The students are listening on Facebook. I'll check if there are any questions there, but I think meanwhile we can proceed unless one of our speakers has a question. Nonofo? Okay, maybe we can move on.
So we're starting at the elements, right? How amazing it is to, let's go back to the topics, please. How students to realize that nebulas in space, these clouds of matter, mostly hydrogen in space, turn into star factories. And that stars don't just exist. There's a process that has to take all those atoms of hydrogen and bring them together as gravity pulls them together. And over time, they turn into a sphere, a circle, if you will, and then they start glowing. But as they start glowing, matter is changing from hydrogen to helium, right, which is the 1 to the 2 in the periodic table, and then it keeps going up to iron, which is number 26. But we're made of, and the Earth's made of other elements, right? Everything from gold and silver. And so what happens is when a star burns out after billions of years and it collapses in on itself, gravity gets so strong that it explodes in a supernova. And when it does that, that's where it makes all these other elements. And how astonishing it is for us to realize the process that it took to get all these pieces that make everything around us. And then after it exploded out into space, it had to come together again, right? Into where the hydrogen in our sun came together and that gravity, and then we came together in our planet from all these elements that were made in stars that exploded and to make our life on Earth. And then we talk about the cycles, remember, in some of the previous podcasts, from carbon and nitrogen and water as a molecule, and how all these come together. But you had to have the elements first. But in addition to the star factory, Einstein had a simple equation: energy is equal to matter times the speed of light squared. What does that mean? It says that energy and matter can become each other. And so we see that as matter comes together. Those of you who've seen the movie Oppenheimer, right, and talks about the nuclear bombs, that's matter going the other way. So a little bit of matter becomes a lot of energy, or a lot of energy can become a little bit of matter. So we take a pause and say, Earth, let's look at space from Earth's perspective. Let's look at it from, what does all this mean to us on Earth? Well, we know we have gravity because Earth has a certain amount, is bigger than us, so it keeps us on the Earth. We know that it keeps our atmosphere above us, right? We know that if the Earth wasn't a magnet that protects us with a north and a south pole, and you can show that as in your classes, right, with magnets and iron filings. And as the sun gives out sunlight, it actually gives out other radiations as well. And how, if we didn't have this magnet that protects us from this Earth solar wind, that radiation would actually kill us. And so how amazing it is that all this can come together on Earth. So the other fun thing is there's a lot of news right now about unidentified flying objects, right? And so you can talk about what it took for life to happen on Earth. Could it have happened other places? And so we have things, right? The big satellite dishes from SETI that are listening from space. But it's definitely an interesting topic as people think about, what about if we're not alone out there? And what does that mean to us? So, Miss Sally, any questions or comments?
I'm just wondering, so maybe Bigfoot is real.
Show me the evidence.
But
Right? Let's gather the facts. There's a scientific process to follow, man.
you just said maybe we're not alone.
Who knows? Maybe they came from somewhere else, right?
Yeah. So, any questions to our listeners and our speakers? Mr. Atinda, do you have a question?
Hi, Miss
Or
Kim. Just following through and seeing how amazing it is as we unwrap the entire topic. Actually, I'm following and I'm learning so much. So much that I've not been able to grasp for the previous uh, knowledge that I've had on the entire galaxy and the space itself. So it's commendable, and I really appreciate. Thank you.
you're most welcome. This is
Appreciate your comments. Thank
Douglas
you.
work. It's Douglas work.
Ms. Sally, can we go back to page 5, please?
Okay.
So we started this discussion with atoms and two forces, right?
Yeah.
And so we want to take this time and go back to some of the previous podcasts. For example, remember in the car podcast, we talked about fuel and how fuel then goes into the engine, it's sprayed in, and how the atoms change, the carbon changes and combines with oxygen and gives out the energy that moves the car, right? But now we're talking about those same atoms that can join together and give off energy, but also things like nuclear bombs. Again, those I just watched Oppenheimer this weekend, those of you who've seen that. And when matter comes together, joins together in a sun fusion, it gives off energy. But when big atoms break into smaller atoms, it actually gives off energy as well. And so it happens in our daily lives. It happens in things we're seeing, right? On our digital devices. But then we take the next step and we talk about gravity. And so it's so easy for us to demonstrate gravity in our lives, right? But then we can take that same thought process and compare it to the sun and us and the sun, but that's not it keeps going. Then you got the sun is part of a galaxy. Well, there's a time where galaxies in space, which are both spinning, can actually collide, because people say, well, what are the odds of having a sun explode and all those elements get scattered and then come back together to make a planet, right? Well, part of that is when cosmically two galaxies can collide. And we mentioned about the Earth and how another size planet hit the Earth millions, billions of years ago, and then helped made the moon. But that helps bring all the elements together. But then we talk about how do we, as people, take care of our own planet and why that's important. And we talked about that in the podcast on nature, but we also want to explore. It's in our DNA. It's definitely part of who we are. We need to get back to space and explore. We have so much to learn. And as students are wondering about all the technology and the knowledge that we have today, and the problems that we have on Earth and help to fix those with science, but preparing to look to the stars and to travel beyond gives us a broader sense of purpose that we could go do that together, right? When we look at space and all that's beyond, it makes us realize how much we need to get along together as a people on Earth and work together to go to the stars. But the simple concepts of what it takes to push a rocket, right? We learn it on Earth. We see the forces. We talked about Einstein's famous equation, E equals mc squared. Well, kinetic energy of a car moving is just 1/2 its mass times its velocity squared, its speed. And Einstein just took that same equation and he said E energy is equal to mass times the speed of light, right? But so he was able to make a comparison based on what he saw on Earth. And there's so many questions that we don't know. We don't know what dark energy is. We don't know what dark matter is, right? We still have so many questions. Really, we don't understand why the Big Bang happened. And so for everything we learn about space, there are more questions and more to learn. So, Miss Sally, we've got about 8 minutes left. Want to open it up for any questions?
Yes. Yeah. And from your presentation, it just gets me thinking of how we still have such a long way to go. And this is a campaign we should have for us to have topics or subjects on space to be included in our curriculums. I don't know if it's happening in Global North. I don't think so in Global South. I think Nonofo, you just look for content to teach on space, or do you cover that? Or it's bits and
Oh
pieces?
yeah, we do have, well, we've got a topic on space, but it doesn't cover much. Like Douglas has said, space covers a wide range of, like, it's vast. You can't finish it up. So we do have a little topic on space, and it doesn't really say much. So when I do my programs, I just look for topics to teach and all that.
Okay. So
How
now
do you make space interesting to the students?
Well, we try to like to bring it to real life, to like how do I say it? Um to try to, how do I say it?
I can help you a
Yeah.
little bit. I've seen one of my sessions, our sessions that we do with your school. I've seen you out with kids. I think you do a lot of outdoor. You try to do a lot of practicals on getting them to understand space, right?
Yeah, and we also try to apply it to real life, to
Ah,
try to show that we, like, we live space, like everything else around us is about space and all that. So I think because we do try to apply it to real life, it gives meaning to the students and they want to learn more.
Agree. That's a really good point. One of the things we do is demonstrate when we make the airplanes, right? We take a piece of aluminum, or British say aluminium foil, and you put that on a piece of paper, and an A4 or 8.5 by 11 letter size piece of paper. Then you fold that into an airplane, and then it flies, but eventually gravity pulls it down. And so you talk about the air pressure that keeps it up, and then you talk about airplanes, right? And how it takes fuel to overcome gravity and to get the lift. But then you talk about rockets, and it's like, okay, well, let's talk about in space. There's no oxygen, so you've got to take your own oxygen, because remember, fire is fuel plus oxygen makes the energy. And so you've got to take your own liquid oxygen and the fuel, take it together and burn it, right? But then if you talk about hydrogen, liquid hydrogen being burned with liquid oxygen, and what's the result of that? Well, hydrogen and oxygen make water. And so you can bring in, even though it's space, you can bring in these things that are going on and bring all this together and integrate it in the students' minds, and then get them excited about how do they use this knowledge, right? Because there are so many jobs involved in making the products that go into space. First designing the products, understanding the science behind the products so you can design them, then making the products, bringing all the products together and integrating them, and then the whole software control, right? And the sensors are such a huge area. So there are so many jobs involved in this that can improve students' lives today, right? Questions or comments?
um, Nonofo, Hillary, any questions? Maybe as we wait, if you can just jump in if you have questions. This is quite extensive, and I'm seeing a lot of very nice comments on LinkedIn and Facebook. I think we have more of comments than questions. I haven't seen a question so far. It's comments, but it sounds like it's a topic that, and especially Doug, when you talk about opportunities in space, I think it's one of those skills that we've not yet explored as humans. And maybe if I speak for Africa, there's so many opportunities. We're seeing a lot of projects that are coming up, but I feel like we still have a long way to go. And maybe in the next few podcasts coming up, we'd love to explore more on how exactly can we integrate this within our education systems. How can we ensure? I mean, we are the youngest population, so you need skills, you need people to hire. You come to Africa, but then we need to be trained. We have the numbers, but we don't have the skills.
Can you go to page 6, please, Miss Sally?
Yes. Mhm.
So one of the focuses of the skills, right, is in Seattle especially, we appreciate a sunny day because we don't get that many, some during the winter time at least, right? And so we talk about the sun and what it means to life on Earth, but it leads to discussions about space and how us working together in space, right? But we've talked about the heat and the pressure in a sun. We talk about heat and pressure on Earth that make cars and airplanes, right? And just how astonishing it is, the basic science behind space and how it integrates all this other science that we can bring together, right? There's some exciting things, right? Like black
Yeah.
holes. And imagine what does a black hole mean, right? Mean to each of us.
Yeah. I think there's a lot to learn. Hillary, do you have a question or comment? And an offer?
Yeah, just one comment on the best way that personally feel is worth interacting with the student at their lower level is there is an amazing module on space interaction in a more simulated way in FETLab. I don't know if we've interacted with FETLab.
No, as we've not yet. Maybe none of us has.
Yeah, it's a very good platform.
Mm-hmm.
It's a very good interactive simulation that
Mm-hmm.
the student get to maybe formulate the galaxy itself through dragging on the screen, and they make the entire galaxy and see the entire simulation of the behavior from the sun, the rotation of the planets, and this sparks a very very great interest in them.
Mm-hmm.
And I feel when we try to interact with such, it's an open source actually, and when we try to engage students with such, it really sparks their knowledge and also bring into their conscious the fact that space is
I think we've lost you, Hillary.
Some really good comments though about the simulating and be able to bring the models home. There are several different software packages out there. Be good to include those in this package. Thank you. Great comment. Ms. Sally, can you go to page 48, please? Just want to put a plug in for the next podcast as we end this. One more minute to go. So the next one is a topic that leads straight off of talking about space and suns, is about light. And we talk about the different lights here on Earth. So that's what next week's podcast is on. Miss Sally, back to you.
Thank you very much, Doug. Maybe just to mention, and also if you would like to say something.
Well, I think this one I would really love because it's one of the topics that really got me going. It got me to to enjoy space even more, because the teacher talked about the white light in class, and I asked about the yellow light because I could see the yellow light from my room, and he said there is nothing like the yellow light. So I thought I didn't understand what he was teaching about, because I lost, like, I could see the yellow light from my room and from my cousin's rooms. And when you look outside again in the sun, the sun is almost yellow. It's nothing close to white. And he says there's the white light coming from the sun. And I lost it when he said there's nothing like the yellow light. So I think this is one of the very topics that are really close to my heart, and I'd want to be a part of this one.
Thank you for your comments. And sodium can make a yellow light as well, but that's a topic of another class. But I think we're out of time today. Thank you everyone for joining. Fantastic. Appreciate your comments. You can get this content from Ms. Sally. Give us your questions. Let us know how we can help.
Thank you. Thank you. Thank you. Thank you, our speakers, and thank you, our listeners. And see you next week. Enjoy your weekend.
Thank you.